Just so you know, there'll be plenty of time for questions at the end of the session. So there's a lot of stuff that I need to cover. So basically, let's get started. And if you have any questions, make note of them, and then we'll have time for any questions you may have at the end of the session. Okay. Let's see. Okay, so today we're here to talk about SQL Azure Database. So today we're going to cover some of the basic functionality, the architecture for availability, and things like that. So pretty much in the webinar, we're going to basically talk about ExpressRoute, Azure SQL Database as a general and overview, performance, service tiers, elastic pools, and we're going to talk about logical servers, security and encryption, SQL backup, and backup and recovery, and we're going to talk about database business continuity, region and geo redundancy, infrastructure as a service hybrid architecture, and SQL IaaS and HADR scenarios. So let's get started. So I just want to give you a little bit about who we are first. So we're Tech Cloud. So currently we hold, more than 80 technical certifications and accreditations. We have, expertise in many different areas, some of which include enterprise architecture for Microsoft infrastructure applications, SQL database and Azure cloud. We have extensive migration experience, for doing like Exchange migration, database migration. We're actually getting into cloud migration right now as well. One of the things that we really, like to focus on is our service delivery, with not only professional services, but we also provide managed services, as well as deployment migration, again, for those on-premise and cloud solutions. We have the extensive management experience. So, from a managed services perspective, if we were to come in and manage your environment, we would definitely be able to very easily do that. We could get you set up and onboarded relatively quickly. All of our stuff is based on subscription, based on a billing approach for everything, where there's no hidden fees or clauses in the contract that you typically see with other other providers. And then we provide superior service. Our service levels we make sure that we aim to provide the best level of service to our customers at all times. And then finally, we can help our customers achieve extensive, total cost of ownership reduction, with CapEx expenditure reduction, and this is all through providing, a well-architected, efficient cloud strategy. All right, so let's start with ExpressRoute. So with ExpressRoute, you can pretty much support a dual 10 gig encrypted connection into the Azure Global Network backbone. Pretty much you could have multiple connections in multiple global regions. So if you're a global organization and you have, let's say a region, in the UK and one in the United States, rather than having your users, cross the pond, so to speak, to access the cloud, basically what they would do is they would set up an Azure ExpressRoute connection in that region. So that would basically prevent any latency accessing the cloud or any of the native cloud services and applications. There's something called peering, which provides direct connectivity into the various cloud services and parts of the Azure cloud. The first one being Microsoft peering, which connects you into a direct path into Office 365. If you're running Office 365 today with Skype for Business, SharePoint, or even Office, Microsoft peering pretty much provides that route if you're using ExpressRoute to connect to those native cloud apps and services. Next, we have public peering, which provides a route into the Azure public cloud services like storage, SQL database, and native cloud applications like NoSQL, Cosmos DB, machine learning, artificial intelligence, things like that. And then there's private peering, which provides a direct path into the VNets where your infrastructure as a service VMs are deployed. If you have VNets configured and you've deployed infrastructure as a service instances in the Azure cloud. So Microsoft allows encrypted site-to-site VPN connections. So you don't have to have ExpressRoute, but it's recommended. Particularly if you want performance and you want to have a lack of latency, then ExpressRoute is the best way to go. But if you don't have to do that, you could set up a site-to-site VPN and connect over the internet. And then pretty much, you could set up a VPN either through your centralized ExpressRoute connection or over the WAN or directly over the internet. Just so you know, though, when you're connecting over the internet, the fastest speed that you can get connecting into the Azure cloud is 100 megabits. So ExpressRoute is definitely the way that you would want to go if you're going to have extensive services or you're going to start deploying instances in the cloud. It's the most secure way as well. All right, so now we'll talk about Azure SQL Database. So as a basic overview, SQL Database is a general purpose relational database service that's provided by Microsoft in the Azure public cloud. It's a managed database offering where there's 3 different tiers: basic, standard, and premium. Basically, it supports multiple structures such as relational data, JavaScript, different like spatial data, XML, and JSON data for JavaScript notation. It will actually support that data. I apologize about that little mix-up there. It's a tongue twister. But the SQL Azure database pretty much delivers dynamic scalability with performance and provides a bunch of different options. Pretty much if you have column store indexing with extreme analytic requirements for analysis and reporting, you have the premium tier, and the same thing for in-memory OLTP for extreme transactional processing. You have the premium tier as well. So each tier will provide more capability with regard to performance and how much capacity and the number of databases that you could actually deploy. So you could deploy them either in pools, elastic pools, or through your standard tier, just in a logical server. Or you can you can pretty much the pool is the best way to go with Azure SQL Database, particularly because rather than you pay for a single database instance, you pay for what you're using in a pool. And so if you're not using all your ETUs and DTUs, which is data transaction units and elastic transaction units, which we're going to get into in the next couple of slides, you could save substantial amount of money. So elastic pools are, if you have a lot of databases and they're not going to hit that DTU or ETU limit, then you definitely want to use elastic pools. And then pretty much with Azure SQL Database, it provides near feature parity with regard to the on-premise or the infrastructure as a service instances that you deploy in the cloud. So further looking at the Azure SQL Database, Microsoft handles all the patching, the updating of the SQL code, and pretty much they seamlessly extract all the way the management of the underlying infrastructure. Pretty much the database shares its code base with the Microsoft SQL Server database engine. Microsoft has a cloud-first strategy where the newest capabilities of the server are released first into Azure SQL Database and then onto SQL Server itself. And then pretty much the approach provides you with the newest SQL Server capabilities with no overhead for patching or upgrading any of these new features, which are tested across millions of databases before they actually hit your on-premise databases, on-premise database servers, I should say. So with regard to performance, again, we have the tiers, pretty much the 3 service tiers that we talked about. They support lightweight to heavyweight database workloads. We have the basic tier, which gives you 5 data transaction units, which provides roughly 5 millisecond read and 10 millisecond write response and latency. We have the standard tier, which gives you 100 DTUs and pretty much provides the same read and write latency. And then we have the premium tier, which provides up to 4,000 data transaction units and 2 millisecond read and write response and latency. So you can see as you get up to tiers, when you go from standard to premium, there's a big jump. There's a very large jump into the number of DTUs and the response time. We're talking about massive scales here. We're not talking about a couple of gigabytes to a couple of terabytes. We're talking 100 to terabytes, to petabytes, a scale. If you're scaling up your database, if you have a very large data warehouse, where you're basically importing a lot of data and you're doing a lot of analysis based on that data. The premium tier really gives you that performance that you really need for something on a scale that large. So pretty much, you build your first app on a small single database at a lower cost per month, and then as that service for that database changes, you can programmatically at any time make adjustments, to meet the needs of your solution. So pretty much, dynamic scalability enables you to transparently respond to rapidly changing resource requirements, enables you to deploy and only pay for the resources that you need when you need them. So you don't have to really provision a lot of storage or SQL database up front. You could start small in the basic tier, and then when you're doing your development, and then pretty much work your way up, to the premium tier as your service need changes. And so you can adjust performance without downtime to your apps, to your customers. So it's transparent to the end users of the systems. So looking at basic tiers a little further, again, you get that 5 data transaction units, but the basic service tier is really, offers good performance predictability for each database hour over hour. And so pretty much it provides sufficient resources to support good performances in small databases that, don't really have high concurrent requests. So if you don't have concurrency, you don't have a need for concurrent requests, then the basic tier is going to give you what you need. And typical use cases are typically, when you're first getting started with the Azure SQL Database and you want to test to see how it works and see how, what your development will look like. And then pretty much, it's pretty much designed, the basic tier for apps that are in development often and don't need a high performance level. So do your development that you need to do in the basic tier, and then when you're ready to deploy to production, then you tune up, you dial up the performance to standard or premium, depending on, what the performance requirements of the database are. So, basic databases are ideal environment for development testing, at a low price point. So really that's really the best option when you're first getting into the environment and when you're first doing your development for your applications, for your front-end applications. So standard tier, in DTUs, basically you get 100 DTUs, and then pretty much the standard tier offers improved performance, predictability, and provides good performance for databases that have multiple concurrent requests like web applications. So typically, and specifically for web applications that have low or medium IO traffic requirements supporting multiple concurrent queries are good for, good candidates for standard service tier. So pretty much when you choose a standard database tier, you size your database application based on predictable performance minute over minute versus hour by hour in a basic tier. So, you have a much better response time, with regard to minute over minute performance. And then you should definitely choose standard tier when your database has multiple concurrent requests. And then, also choose a standard tier for applications that service more than one user at a time, that usually need a higher performance level. So if you need more than 5 DTUs and your performance level is a little higher and you require concurrency, then the standard tier is really going to fit the profile for your database. And now when you move up to the premium tier, again, you get 4,000 DTUs. The premium tier provides predictable performance second over second versus minute over minute with standard, or hour over hour with the basic tier for each premium database. And so you could size the database application based on peak load for that database. And then pretty much the premium plan removes cases in which performance variance can cause small queries to take longer than expected with latency sensitive operations. So if you have applications that are sensitive to latency, then you definitely want to use the premium tier and not get into using standard tier or the standard tier. If you have response times that are, if you have a latency requirement that's faster than 5 to 10 milliseconds for read and write, the premium tier is definitely going to be where you want to be. And then, the premium tier greatly simplifies the development and product validation cycles for applications that have a lot of random performance and variance with writing data, or that can experience query latency. So if you're writing a lot of queries or you're running extensive queries, The first thing you should really do before you move to the premium tier is you should tune those queries, to make sure they're efficient. Because the one thing you don't want to do is you don't want to actually move to the premium tier because you're getting poor query latency or query response, and you think it's the tier you're in, but it's actually the query that you're running that could be the issue. So make sure you tune your queries, make sure that that they're efficient, because if they're chatty or they're not efficient, then you're going to have performance issues, and your DTUs are going to spike, and then you're going to hit the roof, of your DTU limit, and then you're going to have to either, increase your DTUs or move to the next tier of the service. So definitely make sure your queries are tuned. And then pretty much, for the most part, the premium tier use cases have, a couple of these following characteristics. High peak load for applications that require CPU, memory, and I/O, to complete operations that require dedicated high levels of performance. And then finally, database operations known to consume several CPU cores for extended periods of time are pretty much good candidates for the premium tier. So if you have a need for substantial memory and I/O, and your database is going to use CPU cores for an extended period of time, then the premium tier is also, those are some other reasons why you would want to move to the premium tier. And so, the database tiers at a spec and glance, pretty much with the targeted workload, for either any of the tiers is development and production, your uptime SLA is 4 nines, and your backup retention for the basic tier is 7 days and 35 days and 35 days for standard and premium. And then your CPU target workload for the basic tier is low, and then it's low, medium, high for the standard tier, and medium, high for the premium tier. And then really, the I/O latency, that really comes into play here when you're deciding which tier you want to go with. Again, 5 to 10, with read and write for the basic and standard tier, and 2 milliseconds read and write for premium. Now, there's a couple of database solutions hitting the market right now. One of them is called AeroSpike, and what they're doing is they're using these memory type databases that actually provide, up to 0.8 milliseconds response, which is insane to think about. And we're talking at massive scales. There's techniques that you could do to increase performance, like sharding your data. If you start sharding data across instances or across databases, that's a way to distribute performance so that that's a way to distribute your data so you get more performance, for the basic services that are calling out specific, tables for data and things like that. So, but there's different systems that are coming on the market, but I'm sure over time, Microsoft is definitely going to do stuff to improve this. They're also making big investment into Cosmos DB, to be those, those development type, large, massive scale databases too. So, SQL database is always going to be part of their main portfolio, but they are investing into other areas of database, because they want to compete with AWS, with DynamoDB and relational database services. They want to be competitive, and they also want to have, leading solutions. So that's really what you're going to see there. So when you look at elastic pools and ETUs and cost, if you have unpredictable usage patterns, it can make it really hard to manage cost in your cloud application model for database. The elastic pools are designed to solve this problem. The concept is really simple. Pretty much you allocate performance, with your resources to a pool rather than an individual database, and pay for the collective performance of all the resources being used in the pool rather than a single database with regard to performance. So, rather than pay for that single database in those DTUs, put them into an elastic pool. The elastic pool will dynamically expand and contract in terms of the resource utilization. So if you have databases that all fall within roughly the 60%, 67% ratio for performance requirements, then something like elastic pool is going to save you anywhere from 13 to 20 times with cost reduction, because again, you're not really designing your database and paying for an individual database in a tier. You're paying collectively for the pool. And so with elastic pools, you don't need to focus on really tuning the database performance up and down as demand for resources fluctuate, because pretty much you allocate your DTUs or your ETUs to the pool, And then basically, if your databases again aren't hitting 100%, they're not hitting the roof, then you don't need to tune performance. The performance will automatically be managed for you. And then, the pool databases consume the performance resources of the Elastic Pool as needed. So you may have a bunch of databases that have like spiky behavior where they get busy for very short periods where they don't have sustained utilization levels that are hitting 100%. They're staying roughly between 30 to 67%, and so you could deploy many of those databases into a pool, and save yourself all that cost, which becomes very important if you're running a lot of databases in the cloud. And so pool databases consume, but they don't exceed the limits of the pool. So this is really what the requirement is. One of the limitations of going with an ETU pool. And so that's only so that your cost remains predictable, even if the individual database usage isn't. So if your cost is focused on how you're deploying stuff, then Elastic pools with Elastic ETUs are going to be the way you want to go. And then pretty much you can add and remove databases to the pool, scaling up your app from a handful of databases to thousands, all within the budget that you have complete control over. So you control how much cost is going to be associated with your database deployment. So consider, using Elastic pools if you're going to use Azure SQL Database, and then pretty much, you'll have a better cost model and structure for your cloud database. So the pool specs at a glance. When it comes to maximum storage size, for the basic tier, you're getting 2 gigabytes. And then for standard, you're getting 1 terabyte, and premium 4 terabyte. When it comes to maximum storage size per database, you're getting 2 gigabyte, 1 terabyte, and 1 terabyte for the basic, standard, and premium tier. And then when it comes down to the maximum ETUs per database, you have 5 at the basic tier, 3,000 at the standard tier, which is considerably high. Considering that's a standard tier, it's a mid tier, you could still get 3,000, ETUs, and then you get 4,000 at the premium tier. So the standard tier may actually, really meet most of your requirements for probably, a large portion of your databases, with regard to performance. So the standard tier may actually fit, really well for you, if you don't need that, that 2 millisecond, read and response time. And so the maximum number of databases per pool in the basic tier is 500, 500, and then 100 for premium, which I'm sure is going to change over time. I know 100 seems little compared to the basic tier and standard tier, and you would think that with the premium tier, you'd be able to support more of them. But I suspect that's based on, the performance, so the reason why that probably is because, they don't want you to over provision, and then, the platform isn't able to deliver the performance requirements. So, run fewer databases, get more performance, and then basically, there's really not an issue with scaling, from the cloud perspective themselves of Microsoft, and then, okay, so database logical servers. So, pretty much logical server is a managed instance that is similar to a SQL Server instance that you may be familiar with on premises. When you create pretty much a SQL, always a SQL database in the cloud, pretty much you create a logical server which provides you logon accounts and password and administrative rights to the master database on that server, and then all the databases created on that server. So master database, when you're in the cloud, is really the only database that you have. You don't have MSDB or any of the model database or anything else like that. So the master pretty much controls, all the security for the instances that are creating on logical servers. And so the initial account that you use or gets created with the logical server is a SQL account, but then you can set up Azure Active Directory authentication for authentication, for all your databases. So this becomes important because with geo redundancy, and when you have multiple regions and where you're deploying your databases across regions, if you're not using contained credentials, within your database, then when the failover occurs, specifically when it comes to geo replication, you're going to have to manually enter in those credentials. You're going to have to change your connection strings, and so this will add to the recovery time that you could actually recover the system. And so the logical server must exist before you actually create the Azure SQL database. You cannot create an Azure SQL database without one. And then pretty much, the logical server acts as a central administration point for things like, the pool databases, logins, firewalls, rules, threat detection policies, and failover groups. Failover groups is a new thing we're going to get into. It's a new feature in preview that's becoming the new way to do, geo redundancy with automatic failover, so that you don't have to make changes on the fly. The failover happens automatically, DNS is updated, and you don't have to update your application string. So we'll get into that in the next couple of slides, but that's pretty much new with failover groups. And so, with the logical server, it provides a unified namespace for the connection endpoint, for the database access, as well as elastic pools, data warehouses, with a link that looks like database.windows.net. Would be like a path, a connection string into the logical server or the database that's sitting on the logical server. And so now you get further into security, you start talking about encryption. Pretty much SQL database secures your data by providing encryption for data in motion with transport layer security, as well as data at rest with transparent data encryption, and column data with always encrypted. So you get a lot of the same features that you get on premise in terms of the encryption. In addition to that, you get cell level encryption for you to encrypt specific columns or even cells of data with different encryption keys. So you have an extra layer of security. So all this is available in the on-premise instance of SQL. So they're giving you this in the cloud as well. And it becomes more important in the cloud to have the varying levels of encryption, because the last thing you want to do is have your database breached. You don't want your data to be leaked, and you don't want somebody who's not supposed to be accessing data, accessing that data and being able to read it. And so you'll do things like, where you have to have TLS and SSL, in transit, to and from the database, and then your application string, you must specify encryption, and the connection, and not trust the server certificate by itself, because doing so will make you open to man-in-the-middle attacks, where people will be able to, somebody will be able to grab that data midstream and get access to it. So, you really want to consider deploying a hardware security module for central management of your encryption key hierarchy, or, at the very least, Azure Key Vault, should be highly considered, option for your key protection. You have to protect your keys because, somebody gets access to them, they get access to everything. So make sure if you're going to be doing Azure SQL database in the cloud, you're using either HSM, or Azure Key Vault, to manage your keys and to protect them. So additional security in the cloud, there's data discovery and classification. This is a new feature in Azure SQL Database that Microsoft is releasing. It's used for discovering, classifying, labeling, and protecting sensitive data in databases. SQL Database, in addition to that, secures your data by limiting access to your database using a couple of different security options, some of which include, firewall rule authentication mechanism requiring users to prove their identity. So firewall becomes really important when you set up your SQL database, and there's rules that you're going to have to create to basically allow access, from on-premise systems into that database. So if you're running SQL Management Studio, on-premise, and you're trying to connect to that database, you're gonna have to prove your identity by providing, a username and login, and there'll have to be a firewall rule that basically enables the IP that you're trying to connect from. So that's one thing. And then, pretty much you can limit authorization, to data roles, memberships, and then permissions, as well as through security like dynamic data masking. If you're not sure what dynamic data masking is, it's basically like providing a mask over certain types of data, like social security numbers, credit card data, financial data. What it does is it provides a logical separation of duties, so that if people that are managing the actual system aren't supposed to be able to access the data that's being managed, then you'd want to do something like dynamic data masking to prevent somebody from running a statement and actually seeing data. Dynamic data masking by itself is not a full solution. If somebody's really good with writing statements, potentially they can get around that and still get access to the data. So really, encryption, really locking down who's accessing the servers, who has access to what parts of databases, what database really becomes important. So you really want to be able to put in place security standards and permissions, for authorization to what actually users can do with Azure SQL Database, and pretty much control it by user accounts, role memberships, and object level permissions. So a lot of the same, permission models and the security models that you would do on premise, you really want to do in the cloud. But in cloud, you want to be more meticulous on how you're applying security and how you're providing access to prevent breach, because, it is out there. Microsoft's doing a bunch of different things now with security to help, mitigate, situations where somebody can get access to your SQL database. And so you should also apply row level security to control access to rows in a database table based on characteristics of the user executing the query. And then, leverage threat detection, auditing, pretty much it provides an additional layer of security intelligence, that's built in and will detect unusual and potentially harmful attempts to access or exploit your databases. So leverage threat protection, it's built into the platform, use it, make sure your data is safe and protected. And then also make sure that if somebody is trying to attempt to access that database, it'll be caught, you'll get an email warning or alert that you set in the console. Then pretty much you can, lock out the, that IP, or you can pretty much, make sure that your database is protected. So backup in the cloud, pretty much SQL Database automatically creates database backups and uses your read access geo redundant storage to provide geo redundancy. Pretty much these backups are created automatically, no additional charge. It's part of the platform. It's part of the service that when you actually purchase it, this is what you get. You don't need to do anything to make it happen. Microsoft pretty much takes care of this for you. Database backups really should be an essential part of your business continuity and disaster recovery strategy, because it's going to help you protect your data from physical and logical corruption, like things like logical corruption, like accidental data deletion. And let's face it, technology, storage, you get a bad disk, you get bad blocks, and even under the best of circumstances, even with the best underlying cloud fabric with storage, you're going to have a situation where you may get physical corruption. This happens. It's just something that happens. Microsoft is doing something better with file systems, like doing stuff with resilient file system now over NTFS, for a lot of their virtualization technology. But even with that, you have an extra layer of protection for faults in the file system, with error correction, but you could still have physical corruption. So you should really make sure your databases are backed up routinely, and you should be testing your stores. Don't wait to find out during a recovery situation that that your backups you're unable to restore, or you're not able to completely restore, and because that could be a resume generating event. But if you want to keep your backups in your own storage container to have a longer term retention than what's specified in a Microsoft service level agreement, then pretty much you can do that. This is a way to get the long term retention of your SQL database backups outside of what Microsoft will actually maintain for you based on the service tier that you're in. So that's something that you could do to have longer term retention for your backups. And when it comes to recovery, pretty much you can restore the database from a specific backup stored in Azure Recovery Services Vault. When you set up, backup, or when backup gets set up for you, there's something called an Azure Recovery Services Vault, where all the databases get cataloged and pretty much where the information to do backup and restore is kept. Without a recovery vault, you couldn't do backup and recovery. It's also used for Site Recovery Manager as well. There's another feature for Recovery Services Vault. But you can restore a database to a point in time, within a retention period. The operation will create a new database in the same server as the original database. That's the way the recovery will happen. And then you can restore a database to another geographical region. So if if you have a secondary copy that you want to basically do to restore to, or you want to create a secondary copy, then you can pretty much restore to that second geographical region. And then pretty much this allows you to recover, from a geographic disaster when you cannot access your server and database in a primary region. So having geographic recovery becomes really important, because if you do lose that region, it's a catastrophic failure. Data center goes down, the network goes down, the control plane goes down for the fabric. You need to be able to recover your data, especially if you have a situation, because everything works with asynchronous replication. And so, typically, in a failover, you could lose data. So this is really where recovery becomes really important, to be able to recover data that may be lost during that synchronization. You are able to restore a database to any existing server anywhere in the world for the most part. This allows you to restore an old version, of the database to satisfy, compliance requests, or if you need to run an old version of an application to test code. Pretty much you could restore that old version of a database to do your compliance stuff, and then also to do your testing. And then finally, or the two things that you need to be aware of is you can restore a deleted database to the time it was deleted, or any time within the retention period. But the limitation is the deleted database can only be restored in the same server where the original database was created. So you can't restore it anywhere else. So if you delete it, it's got to be recovered on the same server where the database was created. So just remember that if you're going to deploy Azure SQL Database, that's one limitation that you have to be aware of. And so looking at business continuity, typically we talk about, there's a couple of different features, including automated backups and, optional database replication. There's something called ERT, the estimated recovery time. Then you have the RTO, and then you have the RPO. With ERT, pretty much, you need to understand, what the estimated recovery time is and the potential for data loss, for recent transactions. And then with RTOs, the acceptable time, before you're able to recover. And then pretty much the recovery point objective, is the point of, how much data you could tolerate losing, from a disruptive event. So you really need to understand what the ERT, RTO, and RPOs are, and set your service level agreements, to meet those objectives. And this is a decision that you should not be making. You should be presenting these options to management, and let management make the decision on, what the RPO, RTO is for the database and applications. You can recommend the architecture, but you should not be making that decision, because if it turns out that it comes down that the RPO, RTO was not able to be met, or it wasn't sufficient, you don't want that decision fall on you, that you're the one who made that decision. You presented the options, and then let management make that decision. So it's on them, if the recovery time objective or the recovery point objective or the ERT doesn't meet the standards for the business. And then you should have all this ironed out before you deploy your first database. That will be part of any backend to any production applications. And then make sure your business continuity strategy aligns with your ERT, RTO, RPO, and business SLA. And during a disaster, outage is not the time to find out that the disaster recovery strategy doesn't match your business requirements. Again, this could be a resume generating event. If you're the one who really made a decision here and you decided what was right for the business, and it turns out it was wrong. So that's why I'm saying, if you're in a position to be where you're able to go to management with this, create some options, talk about what the limitations are, the potential for loss or whatever that may be, and basically present it, and then let management make that decision. So business continuity continues with Azure SQL Database. Now, this is really what you get in terms of capability. Point in time restore, you get 77 days for the basic tier. You go recover from 35 days for standard and premium. When it comes to geo restore from geo replicated backups, your estimated recovery time is 12 hours with an RPO of 1 hour. And then when it comes to active geo replication, this is really the best option, but one of the most expensive ones. The ERT can be 30 seconds with an RPO of 5 seconds. And that's for all the tiers. You get that same level of protection. It doesn't matter if you're in the basic, standard, or premium tier, you get that same level of protection. All right, so auto failover groups, this is that new feature that I was telling you about in earlier slides. Azure SQL Database auto failover groups, which are in preview right now, is a SQL Database feature designed to automatically manage geo-replication relationships, connectivity, and failover at scale. We're talking about large scales here, not just small individual databases. With failover groups, you gain the ability to automatically recover multiple databases in a secondary region after regional failures or unplanned events that pretty much lead to either full or partial loss of the service's availability in the primary region. The failover groups can be readable in terms of the secondaries, with being able to offload read-only workloads. So if you have a reporting workload that you don't want to run it against your primary database, you could run it against your synchronized secondaries. And then pretty much both the primary and secondary servers must be in the same subscription. You can't have the primary and the secondary in two separate subscriptions. That's something that's a limitation and something you're not going to be able to do. And I don't think it's something that you really want to do anyway. You don't want to have different subscriptions, being responsible for security and replication, for your database environment. It should be under the same subscription. And then auto-failover groups support replication of all databases in a group to only 1 second server in a different region. Now, this is a limitation right now. This is V1 that we're going into. With active geo replication, you can restore to 4 regions, or you can have 4 regions, 4 copies in 4 different regions. So, by V3 of this, I'm sure, you'll be able to, replicate, all your databases to multiple regions, not just the 1 secondary server, where you'll be able to basically use multiple secondaries across multiple regions. But in addition to auto-failover groups in preview, they provide read-write and read-only listener endpoints that remain unchanged. So this becomes really important with your applications, because you don't want a failover event or a regional outage to affect an application, or you want it to be affected as least as possible. You don't want to have to go in and actually start, changing connection strings, updating DNS records, and doing a lot of stuff manually, because that's just going to add to, the service interruption time. So, with all the failover groups, it does all that automatically. And it does this whether you choose automatic or failover activation. Failover switches all the secondary databases in a group to point to the primary. You don't have to do that. That's automatic. Incidentally, that specific feature is also available in active geo replication. That's not something that is lacking in that solution. But the DNS record is automatically updated to redirect all the endpoints in the region that the failover completes. And then pretty much you could set a grace period to help prevent data loss. So now, why is this important with this grace period? So first, before we talk about that, the DNS record becomes important. But the one thing that comes into play here is the cache, refresh cycle. So if you have on your instances, on your web application front ends, a 15 minutes cache cycle, then there'll be a 15-minute interruption of service. So make sure when you're designing your applications and your IaaS instances or your cloud services, if you have an option to adjust the frequency of cache refresh, then you want to make them shorter so that you don't have this interruption for an extended period of time. But the grace period becomes important because if the service control plane goes down for some reason within the fabric, what's going to happen is, SQL Azure Database, if you don't have this set, is automatically going to do a force-friendly failover. So if you're writing a lot of data, all that data may not have made it over to that secondary copy, and you'll have data loss. So what the grace period essentially does, if you set it to something like 24 hours and the control plane is actually just offline or is in a problem state, the failover won't happen, and that'll actually help prevent, a large amount of data loss. And then if you really want to ensure that, that the transactions that you're writing are actually there in a secondary, you could run a statement command called SP-wait for database copy sync. What this will do is, if you're running a lot of writing for a period of time and you want to make sure those transactions are synchronized across your secondaries, you could run that command, and that'll essentially almost guarantee that all those transactions will be in the secondary database. All that's going to really be dependent on latency and secondary response. So, one of the things that you could do with secondaries that you really shouldn't do, but some customers like to do to try to save money, is run the secondaries in a lower tier for performance, because the second tier is not doing a lot of writing. So they go into like a standard tier from premium, to save some money, while a failover is not happening. That can happen. But the problem with doing that is that can lead to extensive data loss and service interruption, especially if you have a really written a write-driven workload that does a lot of writing. And so that secondary should always be at the very minimum, as for a best practice, whatever the primary is set to. So you limit the exposure of a data loss, and you pretty much keep the minimum latency with transactions being applied to the secondary databases. So active geo-replication, this is what's available now. This is the standard now for Microsoft today. This is not in preview. This is what's in production. So active geo-replication enables you to configure up to 4 readable secondaries, and the same with different data center locations. So that's a difference that you can do with failover groups. You can actually have a copy in the same region. So you don't have to have regional distribution of your copies. But the problem is it doesn't really provide the resilience. So because if you have a regional failure and you have multiple copies that are in that region, you're going to lose multiple copies. So that's why, even while it's an option to do so, unless you have a really important reason to do this, whether it's a performance thing or a latency thing with writing to a secondary, then you really want to keep your geo distribution into multiple regions with your copies. And then, customers gain the ability to manually recover multiple related databases, in the secondary region after catastrophic failures, for the services, for loss of services when availability in the primary region. Again, this is a manual process. With failover groups, it's automatic, and then the secondary databases are available for querying, right after failover, and if there's a data center outage and an inability to connect to the primary database. So the secondaries the failover will happen, but it'll have to be administered by an administrator. The administrator will actually have to initiate the failover. So, this could lead to an extended, recovery time, or an interruption of service, especially if that security is not set. If you're not using Azure authentication and you're using different credentials for your primary and secondary databases, and you don't have them documented well, that's an issue that can also pop up to basically do that. And then you also have to, after that failover occurs, the new primary has a different connection endpoint. The connection string has to be updated, along with the DNS record. And then pretty much the one thing that you do get with active geo-replication is that it's available for all databases and all service tiers. That's one advantage that you do get. But again, everything you're doing in this type of solution is manual. No matter what solution you go with, it's asynchronous replication. So the potential for data loss, is there depending on what the latency is between the network connections between regions. So that's still something that's going to be there no matter what you do. But the recovery time objective, becomes really important, with service delivery. So you want to make sure that your disaster recovery process is ironed out, it's planned, it's tested, the process is documented so that you know exactly what you need to do in the event of a primary region going down. And then of course, with geo-replication, with active geo-replication, you could use this to migrate, databases to different regions. So if you have a primary that you want to move to a different region and turn that into a primary, you have 2 ways to do that. You could either do a failover, a forced friendly failover, and turn that into a primary, or if you just want to basically create a completely new copy of the database, so let's say it's for an application or some sort of service or something that you want to start new, but you need an isolated copy of that database. You could use active geo-replication to create that migration. And I believe you might even be able to do that for databases that are on premise as well. So that's something I have to look into, but I think that's an option as well. All right, so that covers Azure SQL Database in the cloud. Now we're going to get into Azure SQL Infrastructure as a Service for high availability and disaster recovery. So typically, when it comes to IaaS architecture, when you're deploying instances in VNets and Azure inside Azure in the cloud, you should select a VM size of DS3 or higher for Enterprise Edition, or DS2 or higher with SQL Standard or Web Editions. If you don't do at least those VM sizes, there's a good chance you're going to run into performance issues that are going to relate to service problems and things like that are going to be visible to end users and customers. And then use premium storage production workloads. Don't use standard storage. It's only recommended for dev and test. Again, that could lead to performance issues that affect customers and services to applications and users. And then keep the storage account and the SQL VM in the same region. That becomes really important. You don't want any latency, or you don't want to have a problem with the storage account, because it's really a requirement to have a storage account in every region. Really, storage accounts aren't really designed to span regions, particularly because service levels are different from region to region, and what you get with your storage account may not be the same in a different region. So you make sure you keep them together, your VM and your storage account in the same region. And then disable Azure geo-redundant storage, geo-replication on your storage account. That becomes really important for performance. And then use a minimum of 2 P30 disks, one for log files, one for data files, and temp DB. P30 disks, there's different sizes, P10, 30, and 40. Each one provides a different level of performance in terms of input outputs per second. So, at the minimum, you should be using 2 P30s. And then avoid using operating system or temporary disks for data storage and logging. You don't want to mix that, same way you wouldn't want to do with an on-premise SQL implementation. And then enable read caching on the disks that are holding data files in temp DB. This will help improve performance a lot, with caching. And then do not enable caching on, any of the disks related to the log file. This can, if you enable disk caching, this can create a problem with, the write-ahead logging feature, and, potentially mess with the asset properties of the log stream. So you definitely don't want to do that. And then, stripe multiple Azure data disks to get increased throughput. So if you're running up into the wall capacity, let's say you're running out of space, and your performance is also your utilization, sustained utilization, your process utilization is elevated and high, and your disk queues are growing on the server, and you have, latency in your performance, then what you need to do is you need to add, more disk, in addition to doing the extension. So instead of just extending, the disks themselves, add disk in groups of 4 and stripe them. That's the only way you're going to get the added performance. So if you're up against the wall with IO throughput, 4 new disks, stripe them, you'll get your capacity increase and your performance increase at the same time. That's a best practice, actually a requirement too, to get increased IO. But enable page compression, instant file initialization, and move databases to data disks, including system databases. This is all for performance. If you want to have good performance, then these are all the things that you're going to need to do, in an infrastructure as a service, SQL instance that you deploy in a VNet in the cloud versus using Azure SQL Database. So high availability and disaster recovery for IaaS. You have a couple different options. One of them, you have failover clustering. This is for, you pretty much have a virtual machine that has 2 or more data disks. The storage pool itself presents a cluster shared volume to the failover cluster, and then the SQL Server failover cluster instances use the cluster shared volume for data drives. Usual load balancer holds the IP address of the SQL clustered instance. So anything trying to connect to that cluster will use, the load balancer will direct or request to the instance that's online, and then pretty much availability sets hold all the resources, which provide fault domains and update domains, and an extra level of protection, in addition to the clustering feature, of failover clustering to help prevent an outage. Next, you have, disaster recovery. Really, this is, for availability too, but you have an always on availability group with synchronous within the region. So if you're not running, always on availability group spanning regions, then you want to do synchronous. If you're going to span regions, then you want to do asynchronous, particularly because you don't want to have a synchronous replica running across a region with a large amount of network latency that'll be created a very large performance impact into your environment. Your SQL Server will run really, really slow. And actually, I don't even think a synchronous solution will work. I think it will fail on creation, but that's another whole thing. But asynchronous mirroring across data center and cloud, that's another option for disaster recovery. The same way you would just do on premises, works the same way as on premises, where you're just basically setting up a primary and secondary, enabling the mirror, and then have an asynchronous or synchronous replication you would do on premise. But in the cloud, everything is asynchronous because of the latency, because you're dealing with regional availability versus data center availability. And, the network performance, in a regional design is not going to be the same as it is in a data center. So I definitely want to do that. And then disaster recovery and failover the primary availability group to a replica node in a local region. Pretty much, that you want to have, a local node in the region. If you can do that, if you have an option to do that, that's going to provide a faster failover and easier recovery. And then, again, Azure Availability Sets holds all the resources to provide the extra level of protection, for an update domain, as for when updates happen, and then for failure domains of the underlying fabric. So this provides an extra level of protection. But when it comes to Azure only HADR options, so all these next options are Azure only options. They're not hybrid cloud options. They're not on-premise options. This is strictly in the Azure cloud. So the first one, you have your SQL always on failover cluster, which is basically a 2-node cluster with a 2-node availability set. The always on failover cluster instance gets built, which requires shared storage, which can be reached in 3 different ways. You could have either a 2-node failover cluster running in Azure VMs with attached storage using a Windows Server 2016 storage basis direct, software-defined base SAN. What that really means is, with Server 2016, you could build out a cluster with storage and basically set up storage spaces direct, which provides you tiering, deduplication, copies of your data, gives you a lot of the same functionality as SAN. You can get millions of IOPS out of it, depending on what kind of storage, you have configured. But, storage spaces direct will give you, performance and the same type of connection as a SAN. So that's one way you can do it. Second way is you could have a 2-node failover cluster running in Azure VMs with storage supported by a third-party clustering solution like Sios Data Keeper. This is a clustering solution for the cloud. This is really designed for failover clustering in the cloud. Has specific features for how to set up the cluster in the cloud, because there's things that has to be done when you're building out your cluster in the cloud. Typically when you're building out a cluster, you install your first node. You set up your IP address, you do all the basics to get that node configured for the cluster. You're on a validation wizard once you have both nodes. But when you're actually going to create the cluster in the cloud, you're going to basically do it 1 node at a time. And when you create that first node, it's going to get an IP address from Azure DHCP. But then when you go to create the cluster IP address for the cluster name and things like that, you're not going to get a second IP address, and the cluster is going to fail. So there's some things you have to do manually by setting a manual address, a private address, that's outside of what the DHCP service provides in the cloud in order for you to get the cluster to actually build the way it needs to. Then the other option is to do a 2-node failover cluster with, running in Azure VMs with remote iSCSI targeted block storage, via express route. This is something, where you're connecting like an Equinox storage array to your VMs through iSCSI networking. This is where express route really becomes important, because if you use an iSCSI, block-based storage that's connecting, from on-premise into the cloud, you want to have as much minimized latency as possible, because if you have a lot of latency, if you're running less than 10 gig, your redundant 10 gig connections, then you're probably going to have performance issues on the instance that's running in that cluster. So you really want to avoid that. All right, so next, recovery solution with availability groups. Here, this is Azure only, where you have an availability group, where you have a primary and a secondary replica, asynchronously, replicating across sites. You have a domain controller on each site. One is in US East and one is in US West. Basically, if US East goes down, US West, you would have to do a forced failover and bring that secondary online. This becomes important with the domain controllers with security, because if you don't have domain controllers, in each of the sites, you would have to use what's called something like an asymmetric cluster with a nested always-on availability group, where you're running essentially a different domain and a different cluster, altogether, for the underlying availability group. And so you would have to, set up security. You would have to have the name, database credentials, and things like that, and you would have to reset up all the security. So, in this design, domain controllers are really a requirement for it to work, properly, and have minimal service interruption when it comes to bringing that secondary replica online, following a regional failure. And so, the other option is mirroring. Mirroring using certificate-based services, from one region to the next. Pretty much you have a primary and a secondary. It's very similar to always on availability group. We have replication using asynchronous replication of databases, but with mirroring, it's a one-to-one copy versus a one-to-multiple copy with an availability group. An availability group, you could have, if you really wanted to, you could have a total of, 3 synchronous and, 6 asynchronous replicas on premise. So you have, many more options when it always on availability group. And then you have something called the basic availability group, which something that's probably going to be something that'll be offered soon in Azure, which essentially works. It's a replacement for mirroring. Where you have a primary and a secondary, but it's an availability group versus a mirror with asynchronous replication or synchronous replication on premise. So next, you have Site Recovery Manager. So you could have Site Recovery Manager where you're replicating your VM block for block into storage and into VMs that are in a shutdown state in another region. So basically, Site Recovery Manager, you basically, you have a run book with a failover process. In the event, US West would go down, you would basically power up the instances on US East, and then pretty much as long as your replication was pretty much in sync and it wasn't that far behind, you'll have either none or minimal data loss in that event. Unfortunately, with cloud, asynchronous replication is really the only replication mechanism that's available. But with ASR replication, you could have, I believe, 5 minutes, 30 minutes, and an hour. So at the very least, you could be 5 minutes behind. So if you don't have something that's writing a lot of data, then 5 minutes may be acceptable. But if you have something that is writing a lot of data, then you'll have 5 minutes of data loss at the very least. And then when you get into blob storage, you can pretty much back up your database to blob storage, your VM to blob storage, and from US West to US East, and then bring the VM online and then do a recovery that way. And that's really an option for that. So now hybrid disaster recovery options. Now this is connecting your on-premise data centers into the cloud. So one of the first options is always on AGs. So this is where you have 3 replicas. You have 2 replicas on a primary data center, running synchronous connect. And again, that could be 3 replicas if you really wanted to. It doesn't have to be 2. But you have a domain controller, on site that's connected, all built on top of a Windows failover cluster with a file share witness. It's guaranteed that you need to have an odd number of votes. So here you have a three replica configuration with domain controller. So the file share witness would essentially provide as a vote in the event that one of the replicas would go down, so that there's always a majority of votes. But now with dynamic quorum witness, in this case there would be 4 votes right now, so there would be even number of votes, which wouldn't be good for the cluster. The failover dynamic witness would remove its vote from the cluster, so it's always guaranteed to be an odd number and a majority node. Otherwise, in this situation, you would probably, if you had another replica, such as a 3rd replica, and you have 4, then you would have to use something like a cloud witness or the file share witness to provide the tie-breaking vote for the cluster, for the availability group as well. So next, you have mirroring. Again, you could use domain-based, Active Directory-based authentication, in where, if you're doing Active Directory integration on-premises into the cloud, then partners do not need to be in the same Active Directory domain, or no VPN connection is required. You could do straight asynchronous replication, over the internet, which I would never recommend that you do. But also too, you could just basically do a site-to-site VPN connection and use certificates to authenticate, the instances and replicate that way. That's probably the best way to go if you're going to do mirroring. You want to make sure you're using, anything you're doing to connect from an on-premise data center into the cloud should be encrypted. You should never do anything that's not encrypted. And I would definitely not do anything, at the very least, having a VPN connection whether it's point to site, site to site, whatever that may be. Express route is obviously the preferred method for everything, but if you can't afford express route, or your company can't afford that, then a site-to-site VPN connecting into your infrastructure is the way to go for that. Next, you have log shipping. Log shipping is one of the oldest methodologies for providing recovery for a SQL database. It's been around for since almost the very first couple instances, definitely before SQL 2005, and a lot of modern architectures it's used as a secondary log protection. So even Microsoft with SharePoint 2016 and 2013, even though you're using replication with always on availability groups, there's also a layer of log shipping that's being done just as a guaranteed second methodology, so that the primary replication solution fails, the logs are guaranteed to be there, through that secondary source. But in this case, you would need a VPN tunnel. There would be agent jobs that run. There would be 3 jobs that run: one that copies logs, one that basically applies the logs, and then one that provides the acknowledgement to the primary that the logs have actually been received and applied, and then the next cycle of copying can begin. But that's something there. And then you have blob storage again, where you can pretty much back up your SQL databases into blob storage, or your VMs into blob storage, from your on-premise into the cloud, which gives you the same options as that we spoke about earlier. And you have Site Recovery Manager, again, an on-premise network into Azure itself. You basically set up a bunch of instances. You basically set up Hyper-V. You install a couple of plugins. There's 3 different server roles that you have to deploy in Hyper-V, and that provides synchronization, replication, and throttling of replication up to the cloud. So this picture really doesn't depict really what it looks like. This really just shows storage. I mean, in theory, it is really storage, but you're running Pilot Lite at a very minimum, where you have a domain controller running, and if you have database servers that are part of that Site Recovery Manager configuration, they're running and replicating as well. So it would really be a VNet where you would see instances that are actually running and deployed. And then all your application instances and your application tier instances could be in a shutdown state, ready to be started up at a moment's notice. And so, achieving true business continuity with cloud, it's not, database by itself is not the full answer. To achieve real business continuity, adding database redundancy between data centers is really only part of the solution. Recovering the application or service end to end, from the catastrophic failure or service interruption, requires recovery of all components that constitute the service. So, if you're talking about, client software or stuff that's running on web front ends, such as JavaScript, web front ends themselves, storage, DNS, these are all components of the overall solution that you have to consider and plan for in the disaster recovery plan. And then, it's critical that all these components are resilient to the same failures and become available within the recovery time objective of your application. Otherwise, you're going to have a situation where parts of the infrastructure in the cloud come up, or a part of your hybrid infrastructure comes up, and then other parts are going to be down, and your recovery time objective is going to be skewed, based on what you originally planned for. And then you need to identify all the dependent services up front and understand the guarantees and capabilities of which they provide. And then you must take adequate steps to ensure that your services and functions will work as expected after the failover. So these are all the things you really have to plan for. It's not only database, it's all the ancillary services have to be considered too. And each one of them will have all their own requirements. So that's why you put together a playbook. You document, your recovery process. You document the order in which services are going to come online. So basically, you would do your database services, your domain controls first, your database services, then your application tier, and then your web front end tier in that order. You wouldn't want to bring your web front ends up first, because if the back end infrastructure, if the application tier, the database tier is not up, then guess what? You're still everything's still down. So you want to have a controlled order for not only for the design for replication and failover, but also the overall design for continuity of service. So now we have discussion and questions. So does anybody have any questions? Just looking through the dashboard now. Let's see. So maybe what we should do is pretty much the questions for the poll. Chat. See what the chat is. All right, so I'm not seeing any questions right now. So what I would say is, thank you everybody for attending this webinar. I guess let me know if you have any questions after this. I could be reached at the following address, email address and website if you're looking for information. And then, please by all means follow up with what you need. So, okay, well, I'd just like to say thank you and, pretty much thanks for attending. Have a good day.